Today on the bench is the new MiniPET from Tynemouth software, and the future was 8-bit. This is a kit, so I need to put it all together. I'll do a quick build video and then test it out and see how well it works. So we have a couple of bags of parts, and we have our instructions here. So the first thing I want to do is open up the bags and inventory the parts, make sure everything's here. First things first, ESD strap. The board for data set number 2, components, plastic standoffs for the case. This is kit B, by the way. This kit is designed to replace the board in a real PET. I have a 2001-N that I salvaged that does not have a board, so that's what I plan to do with this. That 2001-N right now is in pieces waiting to be recoded. This is the power board for getting power from the built-in transformer on the PET. Connectors and components for the board. And okay, that's why it's rattling. Sockets are in there, but they're not soldered in yet. So it's a white board, and the chips are all laid out in the foam here, pretty much where they're going to go. I've inventoried everything. It looks like all the parts are here. It doesn't appear to be any detailed assembly instructions, just a diagram that shows where everything goes, which should be fine. So I guess I'll get started putting things together. The placement of the components shouldn't be critical as far as what goes in first. I'm just going to keep an eye out for anything that might cause interference, but soldering's all done on the backside, so shouldn't be a problem. I'm going to start with all of these resistors and diodes and decoupling caps. Because they're small, they lay flat, and I think I might have a slightly harder time putting them in once the sockets are in place. These here with the dark bands on one side indicate the diode polarity. The diodes need to go in with their band on this side. Use a pair of tweezers here and grab the component by the end and just bend the lead on the tweezers. Time to start doing some soldering. I like to use this blue tack putty adhesive to hold the components down before I turn the board upside down and everything falls out. That's all the small leaded stuff, so I think I'm going to move on to the sockets now. And work my way up. Sockets will be a little taller than these, and then I'll work on the parts that stick up above the sockets. I don't want to get blue tack inside the lead holes there, so I'm just going to wedge it in here on the side. Make sure to press the sockets down so they're flush on the board. And it's time to put in some of these resistor packs. These are polarized, and the pads here on the board have a square and a dot next to the common pin. On these, each of the legs is a separate resistor except for one, which is all the other side of the resistors tied together to a common point. So with this one, the dot is over here, and that should line up with this dot right here. And these are apparently flipped around. And with this one here, we don't want the dot on this side, so we need to flip it around so that the dot's over here, which is exactly how it was oriented in the foam. Got these resistor packs in here, just double checking that the dots are on the right side. Those are all soldered in. Now this one I'm putting in next, and obviously we need to put this one in before we put the switches in, just to make things a little easier. Well, I've got these in now, and there's actually not much left except for headers and connectors. So that's next. Almost forgot this little transistor right here. I have to wonder if that needs to go in there before or after the... We'll do that before or at the same time. If you ever end up with this blue tack leaving behind residue like this, you just need to blot it with a blob of the stuff and it'll pick up what's left behind. The diode is polarized, but you can see flat side, and the LED here has a flat side. The short leg goes in the square pad. Well, the board is almost complete. Headers, connectors, sockets. There are a few parts that haven't been put in yet. Capacitors, switches, transducer, because I don't want to get those wet, and I intend to clean the board here. The back side has a lot of flux on it, so I'm going to scrub that first with alcohol and then with soap and water, and then once it's dry, we'll put the last few parts in, clean up those areas with alcohol, and we'll be done. Oops, that's a problem. I don't want to rub off that number. I covered that number with a piece of transparent tape. We'll get back to work. It's all clean now. After scrubbing with alcohol, I took it into the kitchen sink and scrubbed it with the same toothbrush with hot water and dish soap. Then I rinsed it in hot water, and then I rinsed it again with distilled water so as not to leave any mineral deposits behind. And then I took it out to the garage and dried it off with the air compressor. All those little tiny holes you see there are vias that connect the top and bottom side of the board. You can barely see the traces. I was told this is just a two-layer board, and I have to say I'm very impressed with Dave's layout and routing here. In only 2 layers, and he still managed to keep all of the sockets oriented the same direction. These buttons here can't be put in sideways, and it doesn't matter if they're 180 degrees out. The leads are springy, so it helps hold them in place. No indication which one's supposed to be which, but I prefer the white one for the reset and brown for NMI. Dip switches, and the negative side of the capacitor goes over here on the opposite side of the positive side. This board is just too clean and white and pretty to leave solder flux all over it. I didn't find any specific instructions for putting these Kit B boards together, but they're pretty self-explanatory. There's nothing to this one except a connector. This plugs into here, and the other end plugs into the header on the board. And the power, I use these 4 pins for the older PETs, and the diodes only go in one way. They're marked. Nothing to get confused over. Red wire, positive. And that'll plug into the board here. And the dataset connector plugs in to the header pins right there. Now what's left is install the chips in the sockets, and they should be laid out here on this foam here in the same order and orientation that they need to go into the board, but I'm going to double check everything. You can see they're marked here: PIA number 2, CPU, VIA, PIA number 1. This is the system RAM 32K, this is the ROM, this is the video RAM, it's dual port static RAM, character ROM, CRTC. This is actually not a CRTC, this is a microcontroller that's programmed to work like a CRTC, but it doesn't respond like a CRTC in the PET. There are no registers or anything that you can do with it. All these chips have their legs splayed out a bit, so I'm going to put them on the table on something anti-static and just rock them in a little bit in order to bend the legs straight. See the difference here. Of course, while you're doing that, make sure you don't mix up the orientation. All of the notches go towards the left. Make sure you're wearing your ESD strap when you're doing this. See that? Almost bent a pin there. Actually did bend a pin. That one inward just a little bit more. I don't know if my big head's in the way, blocking the camera, but it's got to be done. Got to look at all of the legs before pressing down. Check all the chip legs. Looks good. I've installed these standoffs to raise it up and insulate it from the surface here. I'm going to do a little bench test here. I need a 9-volt DC power supply, and I happen to have one right here. This is a 9-volt center positive, and it's rated at 200 milliamps, which is cutting it close. This thing is set for 200 milliamps, or expected to draw about 200 milliamps, so this may or may not be enough juice, but we'll give it a try and see what happens. The jumpers here for the power connector are jumpered for center positive. And I hope this barrel is the right size. Ooh, we have it ready. Do we have a composite signal? I think my converter here might be set to the wrong one. There we go. Oh, look at that. MiniPET Basic 4.0, 32K. It just so happens I happen to have a keyboard available and a data set. Cassette seems to work. Let's do a load. So far, so good. On this same tape, I have Space Invaders for the 2001-8. Not sure if that version will work on here. This could be a power issue. Let's push the reset button. I have the data set hooked up to cassette number 2 this time. Comma 2. Pretty sure this this power supply I'm using here really doesn't have enough power for it. We tested the cassette drive, and we'll test the IEEE floppy drive a little bit later. Right now I want to try changing some of the settings. We've got 3 dip switches here that control the ROM version, and with them all off as they are now, we're going to be in MiniPET Basic. We can switch to Basic 4. Changing the ROM selector switches, if I turn on switch number 1, we should come up into Commodore Basic 4.0. You notice there wasn't a startup chime. That's because this is a 2001N, 1978, 1979 version of the PET, which did not have a chime, so the ROMs aren't provisioned to do that. The MiniPET version of the ROM has had that feature added. So we are in Commodore Basic 4.0. We should have the 4.0 commands. Let's try Basic 2. And it looks like we have Basic 2. You can tell by the pound signs right there. And if we turn off, we want both 1 and 2 on, we should end up with Basic 1. And there we have Basic 1 with the asterisk, but no version number specified. If we turn all 4 on, we should get PET Tester. This just runs continuous diags, character ROM and RAM. Some other combinations here will switch the ROMs. Looks like switch 3 will select the business keyboard, which this isn't one of, so we may have a chance to test that out a little bit later though. On this next block of jumpers, switch 1 and 2 select the character ROM. So theoretically, with 1 and 2 on, we would end up with the Japanese character ROM. And the last 3 switches are for the video output version. So with the switch 3, 4, and 5 off, we're going to be in 60 Hz NTSC mode for composite, which will also drive a 9-inch monitor. But if we switch it to a 12-inch monitor, we won't be able to drive composite signal. We'll test that in a few minutes when I actually put this inside a PET chassis. Now the MiniPET that I bought was kit B because my plan is to put it inside of a real PET. Now the PET I plan to use it with is a 2001N that is currently in pieces because I've got it stripped down to get repainted. So for testing, right now I've gone ahead and removed the logic board from my 4032. This has a 12-inch screen, and the first thing I want to do is test this power supply device. I put the standoffs on it here to keep it off the metal. So I'll get the voltmeter, I'll check the output power from this and see if we're looking at a steady 9 volts. And we'll plug in the power transformer here. This doesn't have a big filter cap on it because it's actually utilizing the filter cap in the PET. We have a power light and we have 11.3 volts out on this. So that's volts DC. Any ripple? None to speak of. Well, 11 volts isn't surprising, but I want to check the instructions, go back to the Tynemouth blog and see if it's supposed to be putting out 11 volts or 12 volts. When mounting the board in the PET, you can use some of the existing standoffs. Use this one for the power, and this one here for the cassette. And you can use one standoff here in the back corner to screw the board down to. I do have one minor complaint about the whole thing. I don't know why they couldn't make the board just a little bit wider. This mounting hole here is for that standoff, but I guess they couldn't use the other standoff because it would have had to bring it into the board too far. So would have been nice to be able to screw it down to both. I don't think I can get this one in there, but I'll screw it down right back there. I went ahead and screwed this back corner down here, but there's some interference with ground cables and stuff in the back here. You can see the other mounting post there. The board could have been just a little bit wider maybe and mounted on that. I don't know. I'll plug in the video cable here. It's keyed. The cassette number 2, I don't really need to plug it in, but this is what you'd do if you had a PET with the chiclet keyboard. And then the power cord right there. We're all set. Oops, except for the keyboard cable. That goes right here. And that's keyed also, so it can't go in backwards. Well, here we go. I've got the voltmeter hooked up, and I've been assured that 11.1 volts is within tolerance, but it's also unloaded, so we'll see what the voltage turns out to be with it loaded. I've changed the dip switch here to the setting which should make it work with a 12-inch screen, and we'll turn it on and see what happens. Here goes nothing. We have a chime, and we're running about 10.6 volts with the load on it. And waiting for the monitor to warm up, we have a good picture. I don't have the board properly mounted in the case because this is just temporary for testing, but I have the cassette drive and the IEEE cable connected. So let's turn things on and see if they work. There we go again. Nothing? That's not good. Okay, here goes nothing again. Have a chime. Screen warms up. No cursor. No keyboard response. Now I have the PET SD Plus connected instead of the 2031. I switch it over to standard Commodore Basic 4.0. DD load fader. The picture looks very clear and is rock steady solid. No jitter, no wavy lines, nothing. It looks very good. This is very interesting. Watch this. You hear the sound continue? Turning the power off turns the screen off immediately, but the computer keeps running off the power in the capacitor for a little while because it doesn't draw much power. The problem I had with the floppy drive earlier must have been caused by the way I had it mounted in the PET. You can see here on the bench it works fine. I suspect it might have been shorting out against the ground lug there in the back left corner near the IEEE port. I also tested it with my other floppy drives for good measure. It was fine with my MSD drive and my 4040 dual drive too. Early versions of the PET didn't actually have a built-in speaker, so a lot of users back then and now built something like this. Just a piezo speaker and a resistor connected to pin M of the user port, which is the CB2 output. This one that I built also has a serial port for connecting to a modem. I'll put a link below if you're interested in that. Some users prefer to plug into a powered speaker though for better sound. And there was a user on Facebook, John Erlin, who noticed he wasn't getting any sound from his and asked me to check mine. So I plugged mine in, and I plugged in a powered speaker, and I tried to make some sound. And we get sound out of the little built-in speaker here. But this powered speaker's turned all the way up, and nothing. On the user port, the top contacts are numbered left to right 1 through 12. And on the bottom, left to right A through N. So I checked continuity from pin M to pin 19 on the 6522. This is where CB2 is. And I didn't have any continuity. So I checked with Dave at Tynemouth on Twitter, and he was surprised to hear this, but he double checked and then he realized that he made a mistake. It turns out that on the top and the bottom, all of the pins are mirrored left to right. So instead of pin 1 being over here, it's over here, 1 through 12, which means that CB2 is actually right here on pin B. It's an understandable mistake, something easy to overlook, and Dave has assured me that all of his testers have been sacked. I think probably the majority of users out there would never notice a problem with the user port because there aren't really many things that can plug into it. But if you're one of those few that plan on building something for the user port, just be aware that the connector pinout is mirrored. So what's the verdict? Well, I might be a little biased because I'm a huge fan of the Commodore PET and because I already needed one of these for a restoration project that I'm working on. But I give it an enthusiastic thumbs up. The board is well designed, the kit is well put together, making it easy for anyone to assemble. Other than the problem with the user port, my only other nitpicky complaint is that I just wish the board was a little bit wider so that it could be screwed down to both of the mounting posts in the PET. That's about it. That 200 milliamp power supply that I'm using can't run the cassette motor, but with no cassette connected, it seems to be fine for everything else. Guess that's it for now. Thanks for watching.